In section 2.7, we're going to be talking about some stuff from last chapter and this chapter, kind of combining it. We are talking about absolute value equations and graphing them. So to start out, the parent function for an absolute value is f of x equals the absolute value of x. Some quick notes of what this looks like. An absolute value function is V-shaped. It's symmetrical about a vertical line that we call the axis of symmetry. It either has a max or min value, which we refer to as a vertex, and it looks something like this. So in the parent function, here I could see that line that cuts it down the middle is the axis of symmetry. And in this parent function, I have a low point, so I have a minimum value, which again we refer to as the vertex. Now when we're graphing an absolute value function, instead of focusing on the parent function, we're actually going to focus on something called the general form of the equation. And this kind of helps us account for and notice, again, those patterns that we talked about in the last video, if there is any vertical or horizontal translation or any shift or compression. The general form of an absolute value equation is f of x equals a times the absolute value of x minus h plus k. And just to kind of break this down, that a value represents any stretch or compression, and the value hk is representing the vertex of that equation. So just to go through some example problems of how we can graph, let's say I want to graph the equation f of x equals the absolute value of x plus 2 plus 3. From here, I'm going to look at the number 2, 3. Looking at that, I can see that my vertex is actually negative 2, 3. Keep in mind here that when I have x minus h, technically in this equation, I have x minus negative 2, minus a negative changes to positive. One way to remember this is that whatever number you see with the x, if I see positive 2, that means negative 2 is my vertex. With the k value or y value, it's going to stay the same. So if I see plus 3, that means positive 3 is actually my y coordinate. I know that can get kind of confusing. The more times you see it, the more it'll kind of stick in your head. So the vertex here is negative 2, 3. So I'm going to graph that. And now my a value is 1 since I don't see anything here. And what's helpful is that that kind of tells me my slope. So starting from my vertex, I'm going to go up 1 over 1 in both directions to make that V shape, like so. So now I'll connect all the dots, and that is my graph. Looking at another example, here I have f of x equals negative 1/2 absolute value of x. So here, what's important to notice is that I don't see any numbers like plus or minus with the x or outside of it. So that means that I actually didn't shift at all. So that means that my vertex stayed at 0, 0. My a value is negative 1/2. So that means that starting at my vertex, I'm going to go down 1 over 2 on both sides symmetrically to make my V shape. Like so. Connect the dots, and that's my graph. One last example, I have f of x equals 3 times the absolute value of x minus 2 plus 4. So here I have 2, 4 as my vertex. Again, keep in mind, I saw minus 2. That means positive 2 is my x-coordinate. I plot the point 2, 4. My a value is 3. So that means that from my vertex, I'm going to count up 3 over 1 in both directions to make a V shape, connect my dots, and I'm good to go. I like to compare here in these two examples how my a value can stretch and compress my V shape. So in the one that we just did, my a value is 3, a value greater than 1, and you can kind of see here in our picture that that V is a little bit more stretched out vertically, and it seems a little bit more narrow. On the other hand, in that last example B, my a value is negative 1/2. So the 1/2 is a value between 0 and 1. As you can see, that V shape is a little bit wider. Next thing we're going to talk about in this video is kind of going the reverse way. So if I see a picture of an absolute value function, if I can identify key info, I can easily make an equation for it. So what I need to find is my vertex, which here I see is negative 2, 7, and my a value. So counting over to the next coordinate, I can see here is down 1 over 3. So my a value is negative 1/3. Now I have all that I need to type this into the general form of the equation. So my vertex is negative 2, 7. So I'm going to plug those in. Remember, minus a negative changes positive, so I'm just going to change that now in the absolute value. And finally, plugging in my a value, I'm left with my equation for that graph is going to be f of x equals negative 1/3 times the absolute value of x plus 2 plus 7. Last thing that we'll talk about today is how to put this into your calculator. Now, I think that it's important for you to practice doing these by hand. I think it'll help you understand the general form better. But anything dealing with graphing, I think it's a really good habit to get into, to always graph to double check. Just to see a picture, if your picture matches up with what you graphed, you know confidently that you're good to go. So what's going to be important here is to know how to type in an absolute value when you're graphing these. So in a TI-84, what you would do to graph it, I'll type my y equals to get to my graphing or where I could enter a function. Now if I want to plug in an absolute value in an absolute value function, what I'm going to do is press math. Then my screen will look like this. I'm going to go over to number. And what's nice is that that first option, option number 1, which says ABS, represents absolute value. So from here, I just click enter. That'll take you back to y equals. But now you could see y equals, I have those 2 brackets, and now it's letting you enter stuff inside of it. So just know that if you do math, number, enter, that'll give you those brackets for absolute values to plug them in where you need them when you're typing in an absolute value function.